Hello, welcome to chemistry lesson 5.08, special properties of water due to hydrogen bonding. So we left off in the last video and we talked about the fact that water molecules look like a little Mickey Mouse. Little Mickey Mouse heads. And the oxygen has a partial negative because it's more electronegative and partial positive. So let's do one here. And what can happen is the partial positive of the hydrogen and the partial negative of the oxygen in between different molecules. Now remember, these are covalently bonded together. This is the oxygen and this is the hydrogen and that's the hydrogen. And there's a covalent bond here and there's a covalent bond here. But the partial negative of the oxygen can attract partial positive of the hydrogen, and that's called a hydrogen bond or an H bond for our purposes for short. And we can get the same thing here, and we can get the same thing here. And the result is that water molecules are sticky. They tend to stick to each other and stick to themselves. So water molecules stick together via hydrogen bonding. And that leads to some pretty interesting traits. So for example, water, since what we call sticking to yourself is cohesion. So a water molecule sticking to a water molecule is cohesion. Sticking to the same molecules. And this gives rise to something called surface tension. So if you've ever watched a water bug right across the top of the pond, maybe you wondered how that was. Well, the surface molecules of water hydrogen bond and stick to each other, and the force of the bug down on the water molecules is less than the force of the water molecules sticking together. And it creates this surface tension, and water's got an incredibly high surface tension. Another example is if you put drops of water on a penny on a smooth surface, it'll build and build and build and form this giant dome before it finally ruptures and runs all over the place because of cohesion. Adhesion is sticking to different surfaces. Other compounds or molecules. And an example of this would be water in a thin glass tube. So if you've ever looked at water in a thin glass tube, it looks a little bit like this. We get the column, and then the water actually forms this kind of weird U shape. And the reason for that is the water molecules stick to the glass because of adhesion. Yet another property is called specific heat. Specific heat. So specific heat is the energy needed, basically, E-N-E-R-G-Y, to raise, I think it's 1 mil of a substance, 1 degree Celsius. And water has one of the highest specific heats of any compound. And here's the reason why. These water molecules stick together, and to raise energy, you have to increase the molecular movement. So when we're talking about temperature, we're talking about movement increasing. Well, these guys kind of want to stay together. They really don't want to move around. And it turns out that water has one of the highest specific heats of any substance on Earth. Well, the result is it changes temperatures very slowly. You might say, wait a minute, I just boiled water for my mac and cheese a couple of days ago, and that didn't take very long to boil. Well, actually, it kind of did. If you've ever taken a different substance like rubbing alcohol and poured it on a countertop, it evaporates in seconds. If you leave a puddle of water out, it can take a whole day for that to evaporate. So it turns out that actually water wants to change its temperature very slowly. So this is good though. So what's the benefit of this? It takes things like the oceans and bodies of water a long time to change temps. If you are on land or you're in the middle of a desert, deserts heat up and cool down within an hour. It can be scorching hot. Within an hour, it can be freezing cold because earth and rock has a really low specific heat. It doesn't take much energy to raise or lower. If the oceans did that, nothing could survive. Everything would die. So when they talk about with global warming, the oceans raising their temperatures by 1 or 2 degrees, that's a really big deal. And life can't adapt to that very quickly. So 1 or 2 degrees in an ocean is huge. Um, so for your consideration. The other thing that these special properties do is they give solid, AKA ice, special properties. So this is, and I should have prefaced with this, up here at the top, this is liquid water. So this can only happen when water is in its liquid form. It doesn't happen when water is in a gaseous form, steam, and it doesn't happen when water is in its solid form, ice. So what happens is as we begin to cool the liquid, we actually don't allow these molecules to stay as close together. They have to go into a crystal structure, which is going to be a little bit like this. And they're spread really far apart. So now they're in their crystal structure. And we could keep going, but we're going to kind of do this to show crystal, like snowflakes. Those look very much like crystals. But the crystal structure forces the water molecules apart. So when they're a solid, it goes into a crystal, forces the molecules apart. So there is no hydrogen bonding, no hydrogen bonding. Because of that, liquid water is more dense. So here's our arrow. The liquid form is more dense than the solid. So what's the result of that? Well, the result is that, I'm going to do a double arrow this time, ice floats. And that's good because if ice didn't float and bodies of water froze from the bottom up, all the life would die. So once there's an ice cap over a body of water, it actually kind of helps insulate the water below and keeps it from changing temperature. But if water didn't hydrogen bond, we wouldn't see this. So our takeaways are that hydrogen bonding really does change the way that water behaves. We get cohesion where it sticks together, leading to surface tension, adhesion. It'll stick to other compounds, high specific heat. And let's add this high, very high, one of the highest. Because the water molecules are sticking together, it takes a lot of energy to break those hydrogen bonds and increase the temperature for water. And when we cool it, we force the hydrogen bonds apart and put it into a crystal form. And that gives us a solid that's less dense than its liquid form. Again, you don't see this with very, very few other substances, if any. I can't think of any off the top of my head. But all of that is because of hydrogen bonding. All right, that wraps up this whole chapter. Thanks for watching today. Have a good day.